In today's video, we unpack the probability space, omega, F, and P, the three objects sitting under every stochastic model in finance, statistics, and AI. A probability space is this triple, omega, F, P. Omega is the sample space. F is the collection of events. P is the probability measure. Together they say what can happen, what you can ask, and how you weight the answers. Omega is the set of all possible outcomes. The experiment draws one omega. Probability is never attached to that point by itself. Probability is attached to sets of outcomes. Coin flip. Omega is heads and tails. 2 stories. That is the whole universe. A fair die. Omega is 1 through 6. The event even is the set 2, 4, 6. Probability 1/2 is the weight of that set, not a label on a single face. 1 omega is an outcome, a point. An event is a set of outcomes. Heads is an event because it is the set containing the point heads. F is the list of events, the questions you are allowed to ask. An event is a subset of omega that belongs to F. When omega is finite, you may take every subset. The coin has 4 events: empty, heads, tails, and omega. When omega is a continuum, you cannot. A dart on the unit interval, a Brownian path, a random image. Not every subset can be given a consistent length. So we keep a family F of well-behaved sets, and we only assign probability to those. That family is a sigma-algebra. First, empty set and omega are events. You can ask nothing happened, and you can ask something happened. Second, if A is an event, so is its complement. If you can ask the stock rose, you can ask the stock did not rise. Third, a countable union of events is an event. You can ask at least one of these countably many things happened. That is why it is sigma, not just a finite algebra. P maps each event in F to a number between 0 and 1. P of omega is 1. The empty set gets 0. Disjoint events add. That is countable additivity. It is the rule that makes length, counting, and Gaussian mass all the same kind of object. On the fair coin, P of heads is 1/2. P of tails is 1/2. P of omega is 1. Dart on 0, 1. Omega is the interval. F is the Borel sets, intervals, and the sets you get by countable unions and complements. P is length. A single point has probability 0, yet some point occurs. Probability 0 is not impossible. Every exact dart location has length 0, and still the dart lands. Infinite coin tosses. Omega is every infinite sequence of heads and tails. The event first heads on toss 3 is a set of sequences. Its probability is 1/8. You never write a useful probability for one exact infinite sequence. In finance, 1 omega is a full market history, a price path, a rate path, a whole scenario. The observed price is a function of omega. The asset finished above its start is an event. All histories where that is true. Pricing and risk are statements about P of events, not about the single path you happen to live. A risk-neutral measure is a different P on the same omega and the same F, same events, different weights. That is how you change from statistics to pricing without changing the sample space. In statistics and AI, omega can be a dataset, a mini-batch, or a noise draw. Test accuracy above 90% is an event. Calibration and coverage are probabilities of events in F. Omega is the outcomes. F is the events you can measure. P is the weight of those events. Write random quantities as functions on omega. Compute probability only on F. I hope this derivation helped. This is QuantXYZ, Quantitative Methods for Finance, Statistics, and AI. Subscribe if you want the next one.